Okay, in this video clip I'm going to show you how to use the distance formula. And this should look relatively familiar to you, not in the way it's written now, but it basically comes just from the Pythagorean theorem. What we're going to really try to do here is basically, if we're trying to find the distance from one point to the other on the coordinate plane, we're going to look at it as a right triangle, and we're trying to find the hypotenuse of that triangle. So what we did is rearrange the distance formula to make it fit that hypotenuse. So in this case, instead of calling it h, I'm going to call it d, because that's what we're doing over here. Now, a lot of times when you see formulas like this with all the little ones and twos, it gets people very confused on what that represents. So let's try and take this very, very basic. Okay, I'll see if I can color code it. We're going to label this point 1, just randomly. Okay, it doesn't really matter which one we pick as which, but I'm going to label that one point 1, and I'm going to label this one over here point 2. Okay, so those are my points, and what I'm going to do before I get started is I'm going to label their x and y coordinates. So I'm going to call this x1 and y1 because that's the x and y coordinate of point 1. Then I'm going to call this x2 and y2 because it's the x and y coordinate of point 2. Remember, the first number is always x, the second number is always y, same order as the alphabet. Now, when I look at this formula, all I'm really trying to do is find out basically how far apart are the x coordinates, which is really this distance right, oops, wrong color, this distance right here. And I'm going to try to find out how far apart their y coordinates are, which is this distance right there. Now, as we use the formula, if we take it from that approach, we have distance equals, whoops, wrong color again. See if I can keep this straight. Oops, distance equals, and I'm just going to draw a big square root and see where it gets me. I'm going to start by doing this. Okay, I'm just going to put in the general format. See, I put in the negative signs, I put in the squares, the parentheses. Now I just got to substitute the exact locations. So x1, it looks like, goes right here, and y1 goes right here. Then I'm going to go back over here. Look, x2 is right here. Oops, dang it, wrong color again. x2 goes right here, and y2 goes right here. Oops, I forgot a little square here, which will make a big difference. So now that I've got those in there, let's just take our order of operations and work it down. 7 minus 2 is going to be 5, and then we have to square it, plus 8 minus 3, which is 5, and we're going to square that. Now I'm going to write something else in here that seems tiny, but it makes a big difference. If those were negative values, we're going to square them. We should get positive values. So you got to make sure if you're using a calculator, you do that correctly. Okay, what this is going to give me is basically the square root of 25 plus 25, which is the square root of 50. Okay, and that is not 5. That is not 10. It's not a nice number you should know. It's really close. Remember, the square root of 49 is 7. So this is really close to 7. It's just barely bigger, so it's probably close to 7.1. Probably not even there, 7 point something. Okay, but that's how you use the distance formula. Expect this amount to frequently be a decimal. It's not always going to be a nice whole number. In fact, that's why we use it. If it's a nice whole number, we could just count those units on the graph and figure out how far it is. But since it's probably going to be a decimal that you can't really estimate from a picture, or at least not estimate very closely, we're going to use the distance formula to figure that out.